Okay, just going to look at sketching with y dash and just the steps that you go through. So first step, when you're going to sketch with calculus, you need to find y dash, and then the next thing that you would do, so you find y dash, that's the first derivative, and then you make y dash equal to 0, and you solve for as many points as you possibly can. Usually it's a quadratic, so you'll have to factorise and solve. Like for example, y equals x cubed. Okay, so you got x cubed minus 3x squared minus 9x plus 7. When you find y dash, that would be 3x squared minus 6x minus 9. Factorise out the common factor of 3, be 2 and 3. Factorise the rest. Okay, when you make y dash equal 0, you get 3x minus 3x plus 2 equals 0. 3 cannot equal 0, or you just divide it out on both sides. X would be 3 and x would be minus 2. Then all you have to do is just sub it in to find your y value. Okay, so step 1 is find y dash. Step 2 is make y dash equal 0 and solve for x equals a and x equals b. This will help you find your stat points. Okay, step 3 is you need to find your y values of your stat points. So you sub x equals a into the original. So you put it into the original to find y, and you sub this into the original function as well to find the y value for the b. Then when you are determining the nature of your stat point, you need to have a table of values. So for the last one, you might notice that what we had was x equals 3 and minus 2. You can put them all in one line like this, y dash, so minus 2 and 3, and put 0, because at that point the y dash is equal to 0, because the gradient was 0, and it is 3 on top, 3x minus 3x plus so it's not 2, that's 1, so I'll take that back. That's going to be 1. 3 minus 2 is 1. Okay. So if you come back here, it would have been x plus 1. Okay, so if you look at this now, you just need to get like points in between it. I might actually put 0, because that's a nice easy point, and that should have been a 1, and then 3, and then let's go 4. So notice how I've got this in a factored form. So if you put minus 3 in there, then you know that y dash would be 3 times minus 3 minus 3 times minus 3 plus 1. So it's like a negative times a negative. So straight away you can see the sign is a positive. If you put 0 in there, y dash would be 3 times 0 minus 3, 0 plus 1, which is a negative. And if you put in 4, y dash equals 3 times 4 minus 3, 4 plus 1, which is a positive. So you draw up a table of values and you put the values in between, and then from there you're looking at the sign of the gradient either side. So we know that it goes positive, 0, negative, 0, positive. Go positive, negative, and then positive. So from there you can see the first point is a maximum and the second point is a minimum. So you can do this by doing like separate tables. You can do it all as one table. Now when you're determining the nature, when you're doing the final stat, basically the fifth step is this. Basically if you find that the sign of the gradient goes from positive to negative, that means it would look like positive gradient and then 0 and then negative. So that means that it would be a maximum turning point. If it went from negative to positive, it would look like that. So that means it would be a minimum. And then if it goes from positive and it stays positive, and we know that here it is 0, each of these, that's where y dash is 0. And we're talking about y dash here. When I'm talking about positive, I'm talking about the sign of the gradient. That is called a horizontal point of inflection. Okay, so it is all a stationary point, but there will be a change in concavity there. You can also go the opposite way too. That is also horizontal, and that's the type of stationary point. Once you've got the stationary points, then because you know where they are, when you're curve sketching, you must find the y-intercept. So to find the y-intercept, you put in x equals 0. So for example, if you had x cubed minus 3x squared minus 9x, say, plus 7, when you put in x equals 0, the y-intercept would be 7, because it's 0 cubed minus 3 squared minus 9 times 0 plus 7. So that means that your curve would have to be going through 7. So let's just say we had a maximum here. We'll put that at x equals a. A minimum at b, and at c we have an inflection. So we have that, and here we have an inflection. When you are drawing it, draw them separate first. Right? Draw them like this. And this one's a horizontal inflection. So if you found that was an inflection, that was a minimum, and that was a maximum, and it must go through 7. Let's make that a little bit neater. Join it up then, okay? And just make sure that you don't have this double line thing happening that I just had there. And that it's like a nice, smooth, neat curve like that. Now, as far as the x-intercepts, you only need to find if it's possible. And in that case, you'd be asked to do it. Because sometimes it's impossible to factorise it, so it's not expected. The other thing too, whatever your point is, like say this was A, f of A, I like you to write your point on and C, f of C. Write your coordinates on the point and make sure that you write even this one here, because that's just good exam technique. And then you won't make as many mistakes in forgetting where particular points are.